You ever watch one of those little robot vacuums zipping around your living room and just wonder, how does it know where it's going? Well, I can tell you it's not magic, it's some seriously cool technology. And in this explainer, we're going to pull back the curtain on the incredible sensors that give robots their version of sight.
Right? This is the classic question. You see this little disc heading straight for the edge, and you brace for impact, but then it just stops and turns away. So what's really going on here? What's the secret that keeps it from taking a nosedive down the stairs?
Well, the answer comes down to a whole category of devices called range sensors. You can think of these as a robot's superpower. It's what gives them depth perception. They are constantly measuring the distance to everything in the room, basically building a little map that says, okay, wall here, chair leg there, and, the most important one, whoa, big drop right ahead.
So how do these things actually work? Let's kick things off with one of the most common methods out there, using sound. We're talking about the ultrasonic sensor. And yeah, it works a lot like how a bat navigates in total darkness. The concept here is just so beautifully simple. The sensor lets out a quick ping. It's a super high-frequency sound that we can't even hear. Then it just waits and listens for the echo. By timing how long it takes for that echo to bounce back, it can figure out the exact distance to an object. Now, it's not flawless. A really soft surface like a thick carpet might absorb some of that sound. But for most solid obstacles, it's just a brilliant way to see with sound.
And because it's so versatile, you see them everywhere. They are absolutely perfect for our robot vacuum avoiding that staircase. They also help drones hold a really steady altitude. And because they use sound and not light, they are fantastic for underwater bots trying to get around in murky water where a camera would be totally useless. They're cheap, they're reliable, they just get the job done.
Okay, so sound is one way to see. But what if a robot could use a kind of light that's completely invisible to human eyes? Well, that's the whole idea behind our next piece of tech, the infrared sensor.
So the process is pretty similar, but we've swapped out the medium. An emitter shoots out a focused beam of infrared light. When that light hits something, it bounces back to a little detector on the robot. And by measuring how strong that reflection is, or the angle it comes back at, the robot knows exactly how close it is to an object. The main catch, though, is that really bright sunlight can sometimes mess with the detector, which is why it's usually a better pick for indoor robots.
And because these things are so tiny and efficient, they are in everything. You'll find them in advanced humanoid robots that need to navigate around people, in big industrial arms that need super fine precision, and even in little autonomous toys. They're compact, they don't use much power, and they're perfect for detecting things up close.
So let's just put them head-to-head for a second. You've got ultrasonic, which uses sound. It's affordable, it's reliable, great for general obstacle avoidance. Then you have infrared, which uses light. It's more compact and energy efficient, really good for precise, close-up jobs. See? It's all about picking the right tool for the task at hand.
But what if a robot needs to see, well, everything, all at once, and in super high-definition 3D? For that, we've got to bring in the heavy hitter. We are talking about LiDAR. And trust me, this is a whole different ballgame.
You see, LiDAR doesn't just send out one little beam of light. No, it sends out thousands of laser pulses every single second, spinning around in every direction. It then measures the return time for each and every one of those pulses to build something incredible, a super detailed point-by-point 3D map of its entire surroundings. Now, this kind of detail isn't cheap. It costs more and takes a lot of computing power. But for those jobs where accuracy is everything, LiDAR is the gold standard.
And that right there, that's the game changer. This isn't just about spotting one object in front of you. It is about building a complete, constantly updated 3D model of the world. This is what gives the most advanced robots out there true situational awareness. And the places you find it are just as high stakes as you'd think. This is the tech that lets self-driving cars see pedestrians and other cars with unbelievable precision. It's what lets warehouse robots map a gigantic, ever-changing space on the fly. And yeah, it's how we get those incredible 3D maps of the surface of Mars from the planetary rovers.
So we've gone from sound to invisible light to lasers. But what if we could just copy the most sophisticated vision system on the planet, our own eyes? Well, that is the entire idea behind our final technology, stereo vision.
No, seriously, think about it. Go on, try closing one eye, and then try to judge how far away something is. It's way harder, isn't it? There's a very, very good reason that nature gave us a pair of eyes.
That reason is something called parallax.
Each of your eyes sees the world from a slightly different angle, right? Your brain, being the amazing computer it is, instantly compares those two different images and uses the tiny differences to figure out depth. Stereo vision for a robot does the exact same thing, just with two cameras. The only tricky part is that it really needs good lighting and textured surfaces to work well. It has a hard time seeing a plain, blank wall, just like we do.
This approach is amazing when a robot needs to do more than just measure distance, when it needs to actually understand the shape and context of an object. A humanoid robot can use it to recognize a cup and figure out how to pick it up. An agricultural robot can use it to estimate the size of an apple on a tree. Or a drone can use it to navigate through the crazy, cluttered branches of a dense forest.
So there you have it, 4 really different ways that robots can see the world in 3D. And as we wrap things up here, it's pretty clear that there's no single best sensor. It is always about choosing the right tool for the job.
And this chart breaks it all down perfectly. If you just need simple, affordable obstacle avoidance, you go with ultrasonic. For energy-efficient, close-up work, infrared is your best bet. For that high-precision 3D mapping you'd need in a self-driving car, nothing beats LiDAR. And when a robot needs to understand and interact with the world like a person, well, that's where the human-like perception of stereo vision comes in.
And that leads us to a really fascinating final thought. You know, we design all these systems to try and copy our own senses, but in a lot of ways, they can already do things we can't. They can see perfectly in the dark, they can measure distances with absolute precision, and they can perceive frequencies of sound and light that are totally invisible to us. So the real question is, as this technology keeps getting better, what new things will these robotic eyes be able to see that we can't even imagine? Thanks for tuning in.